Thank you, Yash, for a wonderful walkthrough on Kubernetes. Now we have Nihal Singh, who is a lead engineer at REA Cybersecurity, and he has over 7 years of experience in cloud and DevOps. We will talk about Karpenter today. Over to you, Nihal.
Thanks, Aman. Thanks, Yes, for setting up the context with very easy terminologies. So Kubernetes is not that much easy, what Yash has explained just now. So I will be just talking about Carpenter. So before jumping into the Carpenter, I will just touch about how why the auto scaling is hard. So, so there are several factors. So one of the factor can be slow node provisioning. So traditional cluster autoscale often takes several or few minutes to just launch a node or a table, which can make your pod in a pending state and which can lead to a application impact. The next can be the insufficient resource usage. So generally, there is a fixed node size and poor bin packing leads to resource wastage, like which Yash already mentioned about underutilized nodes. And then there can be a rigid node group. So scaling can be limited with the auto scaling groups where you don't have much options for the like defining which on demand or spot instances you need. And then there can be a cost and performance trade-offs as well, it's hard to optimize between how you can make use of on-demand reserve or spot instances with the right sizing. So so for all these problems, what is the solution? So the solution is Karpenter. So Karpenter is a open source node provisioning tool developed by AWS for Kubernetes. So it offers us real-time node provisioning. It launches the nodes in seconds, and when the pods are in pending state. It also offers us a smart scheduling option which picks the optimal instance type, size, and based on the availability zones. Then it also offers us spot integration with bin packing offerings, which lowers your cloud bills, which is good for cost efficiency. And Carpenter doesn't rely on the traditional auto scaling groups from the AWS because it directly calls the EC2 APIs directly. Next, take a look on how the Karpenter overview looks like. So if you see the above section, there is a pending pods, which are scheduled to existing capacity by Kubernetes. So, so the scheduler or the manager work is to allocate the tables like mentioned by Yes. So the traditional, generally Kubernetes will allocate these pending pods to the existing nodes. But what about if there are some unscalable pods which are in pending state due to the capacity crunch? So Karpenter will come into the picture and it will just launch a new server in a second, and it will place these pods into the new server which just got launched. Then after some time, what Karpenter will do, it will just summarize, okay, there are some capacity which is not utilized properly. So it will reshuffle these pods and create a, you can say, optimized capacity kind of servers, and place all these pods in those servers without having any wastage. Let's take a more deeper dive into this how this optimization exactly works. So, so the above diagram which you see is, you can say, with the traditional cluster autoscaler or without Carpenter. This can be a situation where you are running three nodes instances with a similar, you can say, size, which is, let's say, M5x large. And the first instance is, you can say, fully packed with the pods which it can have. Then there are two other nodes which are just running one pod. So if you don't do anything, this will be a constant situation where you will be paying for the full node, but you will be running just one pod or node into that server. But what Carpenter does it, so there is a concept of consolidation when you enable that. So what Carpenter will do, it will see, okay, these two pod can be clubbed together and can be run into a single node. So it will launch a fresh node. So it will launch, let's say, a M5 large instance, and it will reshuffle both the two nodes into this new fresher, you can say, server. So now you have optimized the node as well as you have saved the cost as well with this. So okay, so that was a general scenario about how the optimization will work. What about the spot interruption? So you can say we can also utilize the spot instances which we get like around 40 to 50% of discount. And with a spot instances, there is one condition that AWS can claim that instance within 2 minutes. So what exactly Karpenter is doing here is it will detect if it gets a termination notice from AWS. So it has a early detection for spot 2 minutes interruption notice. Then it will create a fresh node while listening to the interruption, and it will cordon and drain the nodes. What cordon and drain means here is it will stop that server to schedule new pods, and parallelly it will provision a new nodes with a similar you can say capacity. So now when and now you have 2 minutes to do all these activities, and Karpenter usually provision the node within you can say 35 to 40 seconds. Your new server will be ready, and then what Kubernetes will do, it will schedule these new pods which got evicted from the spot instance, and it will be launched into you can reschedule into the newer pod which has been launched by the Karpenter. So in that way, so Karpenter is giving us the spot interruption handling as well. So with this, does it handle the upgrades as well? So there is a like with Kubernetes, there is a you can say generally problem with the upgrades as well. So let's say you are managing more than 100 servers, and now you have to do some upgrades. You have to change the instances. So either you have to use some third-party tool, Ansible or something like that, or you have to run some script to do these instance changes. So Karpenter also handles the upgrades and check the drift changes. So if there is any changes with, let's say you did a Kubernetes upgrade, so now all the nodes needs to be upgraded. So it detects and identifies if there is any outdated nodes, old AMIs and Kubernetes version. It automatically replaces that with fresh nodes, and it also takes care of the graceful drains of the older nodes. It does all these things with the zero downtime upgrades, and so that it's kind of simplified the life cycle management with like no manual intervention or no patching or upgrades needed. So what about the cost then? So usually Karpenter or AWS claims that if you use Karpenter with on-demand and spot combination, you can save up to 30 to 60% of the compute cost. Karpenter can be like 2 to 3 x faster like compared to the traditional cluster autoscaler. You can achieve more than 90% of bin packing efficiency, where in general case this efficiency is around 6 to 70%. Some cases I have seen it's around 30 to 40% as well. And there is a, you can say PicPay, there is a leading fintech company from Brazil. They have saved around 50% of compute costs by using Karpenter. And in my previous company also, we utilize Karpenters to save around 30 to 40% of our compute cost. So how do we know if it really works? So how will we validate this, that this bin packing is happening, if we are saving the cost, or how it looks like? So there is a plugin called EKS Node Viewer, so which you can set up in your system or in a you can say server, where it shows your Kubernetes cluster nodes, how efficiently they are getting used. So the above diagram you can see it's running with the 98% of efficiency, which is the official you can say image from Karpenter and EKS Node Viewer. And below diagram with the white background is our cluster you can say data, where we have achieved the 80% of efficiency with the spot and on-demand usage. So the above diagram just uses the on-demand instance, but we are utilizing the spot instances. And this 80% efficiency is not the you can say it's the 80%. It can be 90%, and it's just about when I took this screenshot. That time that was around 80%. So in summary, what all the Karpenter is offering us. So it is offering us the smarter auto scaling, which provision nodes in second. It is offering us the consolidation and optimization options. It is offering us the smart termination handling. It also manages drift and node upgrade. So all of these things comes to the cost optimization, which combines speed and efficiency with significant infra saving cost. So I think that's it about the Karpenter. Thank you, everyone.